Rustlings is a great method to learn by example.
I'm just trying to check the URL because it might be something I can actually come back to on my own later.
Yeah, I'll share the URL. This is a free book online. So this is
It's
called,
actually from the Rust language website itself.
it's called the Rust Programming Language Book. And certainly it's free. It's the reason why we use this book in the class. It's actually not my favorite. But the fact that it's a free resource allows us to use it publicly and record videos and put the videos on YouTube and help other people out.
The Discord later.
I can post it in the Discord.
I just added you, Richard, and sent the book to you
Excellent.
in the Rust channel.
So I wanted to do the Rustlings thing because I think in my opinion, it should come somewhere in the learning journey, right? So Rustlings gives you the ability to review and exercise the ideas you've learned in the course of this book and in the course of learning Rust by demonstrating single principles. The exercises are really small. And this idea has kind of blown up in popularity. You'll see it with other languages as well. I think it originally comes from Ruby, but now it's, there's one for C++ we found. I think the last time we taught the Rust class, someone brought it up. There's one for Python. They're all over. And this method of learning, I think, is proven to be extremely valuable. I liked it myself. I've done them all. And I've actually even contributed to the Rustlings project on multiple occasions. So definitely check that out. The other thing that I want to hit on is a question that maybe some people will be asking is, where do I go from here? I know one person has already asked that question, and he's got the book right in front of him. Go ahead and hold it up. This is the Rust Programming Language book by O'Reilly, right? In my opinion, everything about that book is better than the material we have gone over. The only reason why we didn't do it is simply because that book is $50. Not everyone has $50, and if I teach with that book, I can't upload videos to YouTube, right? So they put stipulations on what I can do with that content. However, it goes deeper, and I think it is by and large clearer than the free material we've used. So if you are pursuing a career in Rust, and this is something you want to do, get that book and read through it entirely, understand it 80%, and then I think when you apply, you'll be carved out for a beginner level role in Rust. That everything is in that book to get you going. And of course, there's lots of other books you can take if you're looking for more advanced niches with Rust, whether it's WebAssembly or the locks book that was brought up in the last class as well. So there's other resources out there. But those two I like a lot. So we're picking up on chapter 17. We just did the concurrent web server. And for a real recap, what does it mean to have a fearless concurrency or a concurrent web server?
You can run program instructions concurrently, or side by side, same time, parallel.
In parallel, right? That's what you're looking for,
It's
right?
long threads and not worrying about databases.
Exactly. So we want to be able to do it safely. We want to be able to do it in parallel. There's a slight nuance difference between parallel and concurrent, and if you're interested in getting into that, by all means look it up. But the point is, we want our web server to be able to do two things at the same time. And the way we achieve that in Rust in that last level is with threads, right? And what do threads do?
They are what process the instructions.
Why do we want multiple threads?
So we can utilize the whole CPU.
When we say utilize the whole CPU, we're referring to what?
So all our cores, so like each
That's
core
it.
has like multiple threads.
Exactly, right? So when you write your code in such a fashion that it is threaded, what you're essentially saying is this code can be presented to the kernel in a fashion that it can assign one of those threads to each one of those cores, right? So if you have an 8-core machine and you write a multi-threaded application, your kernel can give one thread to each one of those cores. So what is interesting is the learning curve on Rust is so atypical, right? The learning curve on Rust is such that you pull your hair out when you're learning it at the beginning, because everything is so different and so complex. But in the first book of Rust, you're already writing concurrent programs. You don't see that in pretty much any other language. In fact, I would dare you to find a book in JavaScript or a book in Python or a book in Perl where you're being introduced to the language and they're taking you all the way up into writing concurrent programs. And so I think the breadth of material we're covered is a lot greater, even though the beginning of this class was absolutely and unapologetically hellacious. It's rough, right? What's up?
I don't want to be pedantic, but we don't use multiple threads to use the processor better. We do it to speed up the program, right? That's what the user benefit is. We're trying to make the program faster.
Well, certainly the other method that we didn't do, that definition would hold true. Like if we're using an IO loop, you could argue that it's both concurrent and it doesn't have to necessarily use multiple cores. But the method that we did actually use threading and they use multiple cores. So, yes and no. And we won't get on too much of that. Yes?
Can you go over what concurrency is again? Like, what is it? What does it mean to run?
So concurrency means that you're, at the very core, that word, and this is what the question that we just had raised by Mark, for his point. It means the difference between concurrency and parallel means that concurrent is essentially saying that you are doing multiple things, right, at the same time, right? And those multiple things can be different types of things, right? You're doing different types of things concurrently, technically, when you say concurrent. When you say parallel, generally speaking, you mean you're working towards the same end goal at the same time, right? So these things are slightly different. In some languages like Node, right, a lot of people here come from JavaScript, you can handle multiple requests at the same time. And how Node does it is it does it with more or less one thread. There's like an event loop in the background. And when the event loop is waiting for information, that thing on the event loop sleeps and another thing picks it up within the same thread, and it answers it. And this is why you could say Node is very good at concurrent tasks, but it's very bad at parallel tasks. It's bad at having a lot of things work together towards the same end task. So you will never see Node being used to write things like image processing. Whereas Rust does both of these tasks better. Does both concurrent tasks and parallel tasks better. But the bottom line here is that when you write something that's either concurrent or parallel, if you don't want to get into the nuances of it, what you're trying to do is do multiple things at the same time. Right? Or use multiple resources at the same time. All right. Cool. So what we're going to talk about now is object-oriented programming features of Rust. And why are we going to talk about this? This is an interesting question, in my opinion, because this chapter really doesn't provide to you any value except the ability to communicate with your peers. And we had this communication literally just pop off in the lobby. So it is valuable in communication with your peers. What do I mean by that? I mean that if you come to Rust and you've never touched object-oriented programming and you don't know what it is about, then this chapter will probably not do you much good. But when you're talking about Rust to other people, they're going to hear things like Rust doesn't have inheritance, right? And you should have some kind of answer as to, well, this is what inheritance does, this is how we do it in Rust, these types of things. So this chapter, which I will only briefly go through, is about comparing Rust to object-oriented languages to tell you how that functionality, which you would do in an object-oriented language, can be done in Rust, right? To give us kind of like a shared understanding. Because we're different than them, and we like to think we're better, and that we can do everything that they can do. So this is going to arm you with that reasoning. So the Gang of Four book is it's a book that it's a very scholastic book. If you're into academia, you'll almost certainly read the Gang of Four book. And it's unfortunate because the book is entirely demonstrated with Java. But the Gang of Four book is going to show you design patterns. And design patterns are remarkably useful in programming because they give you ways to think about a problem. Right? Now, I have stressed throughout this class about how we deconstruct problems and how we, as Rust users, implement those solutions with the language. The Gang of Four book is essentially teaching you that for object-oriented languages. So if you do learn an object-oriented language, the Gang of Four book will give you a method in which you can think about when you're writing software and communicate it to others. I implemented this pattern. So one of the concepts that object-oriented languages have is this concept of encapsulation. And what this basically means is that there are things that are inside of an object that aren't exposed except in the ways the object permits, right? And what that means is that, let's say you have an object, and that object is called person. And that person has an attribute called the social security number. Because all of us that stay in America long enough, or were born here, will have that attribute. You probably don't want other people to have the ability to get access to your social security number. So what you want to do is you want to say in some way that that social security number is private, and then you want to give controlled access up to it to people that make requests, like what is your social security number. So this method of encapsulation gives you that ability. And traditionally in object-oriented languages, you would mark those attributes as private, and then you can control access to it by implementing your own method. Get social security number. And then it can check and say, do you have permission to access the social security number? Are you in the right country? Whatever. It can actually control the access to that attribute with that method. You'll see this in every language. Rust also has this, right? In Rust, everything is private by default. So this is a public struct called average collection, and none of these attributes are public. What does that mean? That means you can create, you can have access to this average collection struct type for the purposes of making a function, but you can't actually access these two internal attributes on the struct, right? Because they're not public. So how do you access it? Well, an implementation can access it, and here's how they do it. They're implementing these functions on this struct here, right? So this is add, remove, and this is an implementation for average collection. So we define average collection up here, and then we're implementing behavior on average collection. And here we have a public function called add, and what does the public function have access to? Self.list, right? So this thing here, self.list, this is private. This is not, there's no pub before. So we can access it in an implementation, but other people can't access it, right? So that's how we control access with Rust. This is just to show that encapsulation is certainly something Rust can do. Inheritance is a type system and is code sharing. What is inheritance? Now, this is actually the very topic that we had brought up outside, right? And this is something that I think is less controversial by the year. When I got into computer programming, your benchmark for a language that did it fully, right? You said, well, what language has the most features? What language can do it fully? Was probably C++, right? That was probably an extremely good language to do it. There's, some people would also argue Java is a very good language to do it. I don't know enough about Java to use it here as an example, but there was a concept called multiple inheritance, right? So basically, here's how that works. You can have a person, and a person can be, let's say that a person is a Homo sapien, which is an animal, right? So I descend from Homo sapien, which descends from animal. I have all of the attributes of an animal, I have all of the attributes of a Homo sapien, and then I am slightly different because I wear flip-flops and a jacket, right? So that's what makes me special. And then you can have another thing you descend from, like government subject, right? So then I have to follow the laws of America, or I go to jail, and there's always like rules and procedures along with it, that's social. And you could say, I obey all of these laws of nature, of Homo sapiens and animals, and I obey all of these laws of man, of Texas and the United States and whatever. So you had this idea of multiple inheritance, and this was a really useful method of modeling problems. And again, a lot of this is about thinking about how you're going to model your problems. Well, years and years and years later, it turned out this was a really, really shitty method of modeling problems. It produced solutions that were remarkably complex, everyone hates them, and today most languages choose, even though it's very simple, not to implement multiple inheritance. So we have considered multiple inheritance now to be an anti-pattern by and large. That is not controversial anymore. I don't think you will find anyone that defends multiple inheritance and thinks it's a good idea. It's too complex for most problems, and most people just simply stay away from it. More controversial is whether or not single inheritance is a good idea. Is it a good idea to define me based on a Homo sapien? That's a really problematic thing, right? Because you could say something like a Homo sapien has a brain, and then you have a real problem. You have like baby K, which is born without a brain, right? Chronic microcephaly. Is she a Homo sapien? Those types of issues frequently pop up. They pop up in computer programs too. It's a lot difficult to work around that rigidity. So in any aspect of this, you will find that inheritance is challenged. And the Rust method of doing this is somewhat different, right? We have traits. So you would take the traits of a human, like what kind of things make a human, and you would break them down, and you would say, this being Evan implements all of these different behaviors, right? He works, so he has to obey all the laws and employment law and whatever. And he lives in Texas, so he has to obey all the Texas laws. Texas is in the United States, so if he implements Texas, he implements the United States. And you look at it a different way. You look at it as in like, this is who I am, and these are all different little buckets of behaviors that I implement. So what we're getting to here is that Rust doesn't necessarily have this inheritance idea, but we do something else. And this something else allows us to do polymorphism. What is polymorphism? It's accepting multiple different types of arguments in the same function, right? So how do we do that? We do it with generics, we do it with type traits, I can say this function accepts anything that has a brain, right? Now, I may not accept ABK, but that's because I require everything to think, you know? So that's how we've like went through all of this type of stuff before. This is just giving you vocabulary, right? Go to the next one. Using trait objects that allow for different types. This is exactly what we're getting to. Defining a trait for common behavior. You're going to see here public trait draw. Now we have a trait that defines a behavior called draw. And anything that can draw implements that trait, right? So what do? We can just simply say right over here, this public struct screen implements a vector of things that have this draw trait. That's the syntax for it. So now anything that can be drawn can be put on a vector in the screen, right? And what does that mean? Well, think about like if I have a tree, and the tree can be drawn on the screen, that can go in that vector. If I have a person, then the person can be drawn on the screen, that person can go in the vector. And then maybe I have a vector of 20 or 30 things, in the industry we would call them sprites, I want them all drawn, I can just simply say draw everything in the vector. I know everything in the vector can be drawn because I'm defining it right here. They're all drawable, right? So that's how we do that in Rust. And then here's how they're showing you. Now because we do it, we have this screen, we know everything that's in the components can be drawn. So here's an implementation on the screen, and when we call run on it, it's going to iterate through every different component, and it's going to call component.draw. And really quick, as another note too, two people just got up and walked out. That is totally cool. So if this is not your cup of tea, by all means, feel free to exercise that same ability.
No, man.
Yeah.
I'm here to stay.
Well,
Good little fucking coat iron. Muscles.
I hope some people read some of this material, and if you have questions on it, by all means ask. So now we're going to talk about these traits, these behaviors, right? And here's how we do it. We have a public struct button, and now we're implementing draw for a button. And now in order to make button drawable, right, we implement draw, and we define how it draws, how you draw the button. And then here's an example with this library called GUI, and we have a select box, which has a width, height, and options. And in order to draw the select box, we implement draw for the select box, and we have this function called draw, and it's going to take self, and we're going to tell it how to draw that select box. So here's an example of what that looks like. And to be totally honest with you, this is kind of how GUI toolkits work, generally speaking. A GUI toolkit will generally have a component or a widget. That widget will implement something called draw. Generally speaking, those widgets will also implement something like onClick, if you've used JavaScript, or onMouseOver, or onBlur. All of those things are essentially traits that you can implement in different components and talk about what happens when those traits are triggered, right? So some like Angular widgets or whatever, may react dynamically on the screen because you've implemented a trait that says how they should react. And we've also taught Angular in the past too. All right. And then dynamic dispatch. So to talk about dynamic dispatch, Rust has two different methods of calling code. One of them is called monomorphization. It's a weird word, we don't usually say it, but we write it a lot. And what that means is that you tell it behavior, like draw, right? And then I have a function, and it could accept any type of object. Rust can, at compile time, when the function is monomorphized, it'll go through and say, I need to have a copy of draw for a button, for a select object, for a person, for a house, for a tree. And it'll generate different code for all of them. Because it knows it's going to need a different implementation for every one of those different objects. Right? Rust and C++ both do that. And the advantage to that is it's super fast, right? When you call tree draw, it's just as fast as if you've written draw specifically for a tree. If you call person draw, it's just as fast as if you've written the draw for a person. That process means that every time you apply a different variable type to that function, you have to generate a new copy of that function to make it natively run maximally fast. The other method of making something run is dynamic dispatch. And with that, you essentially say, if I get a tree, do this. If I get a person, do this. If I get a select box, do this. And it's all in one function, right? So if you do that, if you have this if, and you're checking your argument against all these different types, it's never going to be as fast, right? Because now you've got extra logic in there that you shouldn't otherwise have to have. So those are the two methods that every language tends to provide, and it's saying that Rust also provides it. And this is what they're saying here, this, when you use generics, you get monomorphization, which means more code, but faster. And if you don't use generics and you use the trait objects, you get slower code, but you get less of it. So, state objects. Okay. So, what are we showing in this one? Okay. So here we have a state, right, for post, and that state is going to be anything that implements state, right? So there's a trait called state and a post which can have anything that implements that trait. And the reason why they're doing that is any user can create a different state for that post. So this may be necessary if you want to have like a tag, and that tag is going to be like selected for Houston or whatever. You can create custom states using this method. I'm not going to go too much into this because this is like just showing you a whole example with this concept of a state object. But by all means, hit it up and see if you have any questions on it. You know, there's just the point where that's probably too much code to literally walk through all of these examples. Patterns and matching. Okay, so we went through this before, and this is about the intricacies of like patterns. And who remembers what a pattern is? Max?
So like, I mean, if we're talking like a match statement, like you might have a result and it can be sum or error. So,
Right.
So, you know, you might match that, or if you get an enum with more types, you know, you can use like, you know, the underscore to match the rest of it. Is this kind of what you're looking for?
Sure, yeah. So match generally can be one of two things. It kind of mean that you're matching the shape of the object, right, like a tuple, right? A match for a tuple would have two different values, A, comma, B, that's a tuple of two things. Something that matches that tuple would have a shape that's the same, with two different variables. The other thing that you could do is you could actually match the arms of the struct, and that's a great example, option and none. If you're matching a result, another one would be OK, which is for success, or error, which is for the error side, right? These are all different patterns, and the act of using those patterns is called matching. Well, here's a different way to think about it. Some patterns are what they call irrefutable, and other patterns are refutable. And what does that mean? That means that some patterns can be known at compile time to work, and some patterns can't, right? And we're going to go through some of that stuff here. But if you know the pattern to work at compile time, you can do more things with it, right? So here's the match patterns that you're talking about, and here's none and some, exactly as you said. And now we're saying for x, if you get none, pull this across. And if you get some, then we would say unwrap the I and add 1 to it, right? Conditional if-let. Now, an if-let pattern accepts a refutable pattern. It doesn't accept an irrefutable pattern. Why wouldn't this accept an irrefutable pattern?
Because if it's irrefutable, then it's not needed, then is it?
Exactly, more or less. I mean, we could say it a little bit more elegantly, but that's exactly right. If it's an irrefutable pattern and you put it in if-let, it's always going to be true, right? So you may as well just remove the if-let, use the pattern outside, and then just start the next statement, right? So what do we want? We want a refutable pattern right here. Why? Because maybe favorite color is none, in which case you're going to run the code below it. So the whole purpose of if-let is to say, if this thing is true, then do this other thing. In a refutable pattern, we know it to be true, and you're just writing shitty code. So Russ will actually come back and say, that case is always true. I know it will always be true, so you're just writing confusing code. Just remove that condition, and it'll do that. While-let is the same thing, right? So while-let sum pop equals stack.pop. If we know this will always be true, then this is always going to run. It's just a loop. The thing about this one is we're popping off the stack. Eventually we get to the end of it. There's nothing left to pop off, and then we get a none. And then that doesn't run, right? So that while-let there is essentially just like an if-let, but it loops. For loop is the same thing. this pattern right here, now this one is slightly different because this pattern we know has to match, right? So this has to be an irrefutable pattern. So we know that v_iter_enumerate has to return this. Because if it doesn't return that, then you're going to get a compile time error. It's going to come back and say, you know, cannot deconstruct v_iter_enumerate into an index and a value. So for requires an irrefutable pattern. It requires a match. And if you don't match this, if you don't match what this thing is returning, you can't iterate over it. Let also requires an irrefutable pattern, right? So now this is a special thing. Does anyone remember the word that we use when we do this? Let pattern equals expression.
How do you put the type?
What do we call the act of taking an
Assign.
expression and doing something to it to break it down into a pattern? It's this word right here, right? Yeah, so that's the word you may want to use because that one, this idea here, let x, y, z equals 1, 2, 3, you'll see this in like JavaScript. And we just would call this.
When I see that one, I understand it.
Yeah. And why does this always have to match? Because let's say you don't have a z here, right? Well, then we don't know what to do with the 3. So Rust is always going to say match it. And you may say, well, what if I don't want the 3? Then Rust will say put an underscore there, right? So you can have x, y, comma, underscore, and then it'll just throw away the last variable. But you have to have the same shape of the thing on the right as the thing on the left. Function parameters. These also have to be irrefutable, right? So you can destructure like this. This print coordinates here is going to take a reference, right, to a tuple with an I32 and an I32. And what is it going to do? If this matches, you can call the function, and it's going to destructure them like this, x and y. So it's actually putting the destructuring right in the argument itself. So you can call it by that name later, x and y. So this is also a feature that TypeScript has. And here's the explanation of refutability, which is just what I said. If it's refutable, it may not match. If it's irrefutable, it always matches. And you have different contexts for those things. Does anyone have any questions on any of this stuff? We went over all of this stuff in the past, in passing, and now we're going over it specifically and explicitly. So to make, like, I guess to make it more conscious, right?
Yeah.
Matching literals, here's another thing you can do with a match statement. Let x equals 1. Now notice these are no longer arguments, these are values. So the 1 here is the same as the 1 value here, so you're just going to print this out. So a match statement can actually be rewritten to like a switch in some languages or an if statement with values. And matching named variables, here's a great example here too. Match x, we have sum 50, and what does x equal? Sum 5, so you're not going to get this. Are you going to get y? Sum y? Yes. Right? Because y here isn't a value, it's a variable. So 5 is going to get assigned to y, and it's going to say matched y equals y. Right here, this is what's going to get output. And then if it is none, right, it's not a sum at all, you're going to get this. Now, who remembers the example where we did this exact thing earlier, and we didn't know the names of this? We didn't go over the complexities of irrefutability and all that other kind of shit. Anyone remember this example where we taught this? This was like the first class. Anyone remember the quarter example?
Oh, yeah.
Quarter example followed the same thing. We didn't have the vocabulary to talk about it. We're just showing it off. So that's the purpose of this chapter, right? If we come up here or we go down, let's see here. Yeah. Rustling, quarter, penny. Right here. So here, we have a value, coin penny, coin nickel, coin dime, and then coin quarter, where we're setting state. It's the same thing. State is not a value, it's a variable, and then we're printing it out here. So this is a value, coin penny, coin nickel, coin dime, all of those are values. State is not a value, state is a variable, so we get to use it right there. And you'll see that it's the same thing here. Value, right, variable. And then if the variable doesn't match, we essentially do the default case. I think if we scroll down, we'll actually see a default here too, right there, with the dice roll. So again, just trying to show that we've already learned all of these concepts, so we should breeze through this. Multiple patterns, here we go. This is new, 1 or 2. We can all tell what this does. It's just a shorthand. This is or, 1 or 2. Just saves you from having to copy the condition. This dot dot equals means what? What does the equal mean right here?
5 includes 5.
It includes 5, right? Because if you don't have the equals, then it is what?
It's 1 to 4.
It's 1 to 4, exactly. Or you would say it's an exclusive range. So the equals makes it an inclusive range. You're inclusive of the last point. Otherwise, you're simply excluded. Most programming languages define a range as including the first point and not including the last point, right? So if you say 1 dot dot 5, it's actually 1 to 4. If you say 0 dot dot 10, it's 0 to 9. And this gives us the ability to change that. Same thing with this, right down here. We can also do it with letters, A through J, K through Z. The equals makes it include the last one. It's a lot nicer. Okay, so here's another one. Let P equals point. We're defining P to be this type up here, a structure point. And then here we're destructing it, right? Destructuring it. We're saying take this P, and we know it's a point, so we're going to destructure it like this. Assigning whatever is X to A and assigning whatever is Y to B. This is an irrefutable pattern, right? We know it has to match, or the compiler will bark. And I'm going to skip a lot of this stuff. Okay, ignoring values in a pattern. We went over this too. We've used this before as well. And like I said, we used it in chapter 2. There's our underscore right there. It means anything. Match everything. Ignoring an entire value with underscore. This means, for the purposes, match it, but just ignore it. We're not going to keep it. So this foo takes an X and a Y, and what this is saying is ignore the first value that you get. Maybe we'll use it later, maybe we won't. Ignoring parts of value with a nested underscore, it's the same thing. If you have an underscore here, then it's going to ignore it, and it's always going to match it. And here, this is going to match some of anything, but we don't care what the values are. So here's another thing. Rust will complain if you have a variable that isn't used. This is a unique thing. It's kind of a pain in the ass. The language gives you the ability to turn it off. But in order to get around it, what Rust suggests is that you prefix the variable with an underscore, which basically means I may use it later, but I'm not using it now. And then that's like a convention that Rust enforces.
Will it complain if you start using a variable with an underscore that starts with an underscore?
So it'll be a question. I'm almost certain yes, just because I know kind of like the philosophy.
Yeah.
But I can honestly say like I've probably never done that to test it. So by all means, give it a shot. If not, I'm going to start naming all my variables with an underscore. Control hard. You get it?
I just made a new Rust project.
Here we're defining the point, x, y, and z, and we say let origin equals point, and then we're giving all these different values here. For a 0, 0, 0, this is the origin, and then we're saying match origin point, we're just pulling off an x, right? So here's what they're showing you is we can ignore everything else with the dot dot. So if you don't have the dot dot, Rust says match everything. If you want to ignore it, add the dot dot, and then you'll ignore everything else. So underscore ignores a value, right? Giving an argument, dot dot ignores everything. That's not explicitly stated. So here match numbers, first, dot dot, last. This is interesting. You're pulling off the first and the last. Rust is smart enough to know how that works. That's really cool. So you can get the first and the last thing with this and skip everything that does not complain. Does not complain. There we go. We have a new convention. Roll hard. Let numbers 2, 4, 6, 8, whatever, 2, 4, 8, 16, 32. Match numbers, we're only pulling off the second. Here's a method in which we can do it. So you can use match for pretty much everything. Match, underscores, and dot dot for everything. Here they're just pulling off the second. Extra conditionals with match guard. Match guard is an additional if condition. So right here, this is called a guard. In some languages, this is a functional thing. Those guys would probably know this. This is essentially a method of protecting something at the top. So you would typically do this if you wanted to catch a specific type of error or something. You know, you could say error, X, and then if X equals whatever, you know, or X has a specific trait. You will not see it that often, but yes, you can use match currency. 4, 5, or 6, if Y, then print yes. So what are they doing here? We are matching X, and we're only going to execute these 3 things if Y is true. There's an example. Otherwise, this thing doesn't run at all. So that code, in my opinion, is probably not the cleanest in the world, but kind of cool. And here's another example above, where they're only matching N if N equals Y.
You can combine all these things together.
Yes, you can. Whether or not you should, whole other question.
Yeah,
You can.
it is a little hard to read sometimes, a little bit harder than it could be probably.
It's a tool, can make pretty things or complex things. So here we're matching a message, and we're saying here, we have a hello message, and it can either be this, and what they're doing here is they're saying, store the ID in ID variable, only if it's between 3 and 7, that range. They're saying here, otherwise, if it's between 10 and 12, do it here. Otherwise, match everything with this one down here. This pattern makes the thing effectively irrefutable. So if it's between 3 and 7, run this. If it's between 10 and 12, run this. Otherwise, run this. All right. Advanced features. Okay, I'm going to skip over unsafe Rust entirely. So that's, we're not going to go over that. Unsafe Rust is more or less at a high level. Rust is memory safe, but sometimes you're interoperating with languages that are not memory safe, so you have to break rules. In order to break rules in Rust, you can use this thing called unsafe, and it allows you to break a lot of rules. So you can write dangerous Rust code. Why would you need to do that? Well, sometimes you use a language like C, and it just gives you a pointer to a block of memory. And Rust says, well, how the hell do I know what's behind that pointer? And you need to tell Rust, trust me, I know what's behind that pointer, and I know that it'll be there. And that act of saying, trust me, I know what's behind that pointer, and I know that it'll be there, that act requires unsafe. And why is that useful? Well, it's useful because I can audit code and say, these are all the unsafe blocks, make sure someone smarter than you reads them, right? And the reason that works out really well is because a lot of those assumptions are invalid. And in Rust, it's very looked down upon when you use this when you don't need to. So famously, one of the fastest Rust frameworks is a framework called Actix, and that guy essentially wanted to game the benchmarks. This is like when Rust was blowing up in popularity. And he basically said, I don't care what I have to do, I want Rust to be the fastest language ever. And he would game the benchmarks like you've never seen, doing things that don't look like Rust code. He would just wrap everything unsafe. And he was extremely, ridiculously smart. So he got away with it. And Actix became the #1 library for Rust. But it pissed off a lot of people. Because Rust prides itself on being memory safe, and here's one, asshat that's going around writing code that is entirely unsafe, but extremely fast, and everyone's using it. Because they're like, look, now my framework is so fast. Well, people that were even smarter than him showed him that every block of that unsafe that he wrote, even though he's exceptionally smart, was unsafe and could be exploited. So it became like a hobby to troll this guy and find how you can exploit every one of his unsafe blocks. To the point where he rage quit the Rust community, getting sick of it. Anyway, a lot of drama, but really funny. So the point is, even if you're exceptionally smart and you're writing one of the world's fastest web frameworks, using unsafe can be dangerous. And when people find out you're doing it, you're going to get trolled.
By me. By me.
There you go. We know you like ice.
I know that you are one of mine.
Public trait iterator. Okay, so here's a trait, and this trait has a type in it called item. And what are we doing here? Well, there's an iterator that we can implement, and that iterator requires us to define an item. So you can only implement one iterator on your object. You have to define the item for it, and this is going to return the item that you've got. So what is the item equal to here, right? What is it doing here? Well, it's going to say that next must return whatever the item is of the trait. So in this example, you're implementing one trait. You can't implement multiple traits, and that trait is defining a specific item type. Now, in this example, we're setting the implementation to an iterator of U32. So now we have an iterator, right? And by the way, recapping on iterators, it essentially means I can take this thing iterate over it, and every time I'm iterating over it, I'm going to get a U32. So where would this be useful? It would be useful if you had a list of prices in pennies, for example. It's typically U32. So you're iterating over your list of prices, and every time you're getting a new price in pennies. And then there you go. That's how you could write that. This one down here, public trade iterator, notice how this is different. This public trade iterator has one item. This public trade iterator is for iterator of T, right? This means that it is a generic trade. So you can implement an iterator for multiple different types. You can implement an iterator for int, an iterator for float, whatever. And then I could have a type that is like price listing, and maybe sometimes you want to iterate and get 64-bit integers. You can do that. You want to get 32-bit integers, you can do that. You can implement it for multiple different types. Maybe you want to get the actual, you iterate over the price list, but you want it to read it out to you in English. You know, whatever, you can do that. Now it's not even returning numbers, it's returning letters. So here's another example where we're doing this. We have this point, which is an x and a y, two different values that it's storing in this point type, and we're implementing add for it, okay? So think about this, when we have a point, we can potentially add different things to it, right? Like I could have a point that's 0, 0, and maybe I want to add 1 to it, in which case the point should be 1, 1. So I'm adding it to the x and the y. Maybe I want to add another point to it, right? Here's an implementation of an add where we're simply only ever implementing it for point. So this implementation for add adds one point to another point, right? And they're showing you how it does it. It takes self, which is the point that I am, and then you're giving me another point, which is other point. And what are we returning? We're returning a point. So I'm a point, I'm taking one more point, and I'm returning a third point.
Could you implement different versions of add, I guess? So like let's say you wanted to be able to add, you know, U32s and other points to points.
Then add would have to be generic.
Gotcha.
The trait add would have to be generic. This only allows you to implement one add for point.
Gotcha.
There's only one trait implementation for that. This one, on the other hand, speak of the devil, is exactly what you're talking about.
Gotcha.
This one allows you to add any right-hand sided type to point, and it's defaulting in that implementation itself. So the default is, I'm going to take another thing that's the same type as me. But you could add a U32 or U64 or whatever to the point, and you would define that behavior. And you can implement multiple of these traits, right? Because it's a generic. So you'd implement an add for U32, an add for point, whatever. Here's an implementation of add for meters for millimeters, right? So the type is millimeters, and we're teaching it how to add meters. And then that's how you do it. So self add, we're going to take self, which is a millimeter, and we're going to add a meter, right? And we're going to return millimeters. Fully qualified, by the way, if you ask me, this is a typo, because this says output millimeters, so what this should say is self : output. For consistency. Fully qualified syntax for disambiguation. Calling methods with the same name. Trait, pilot, fly, wizard. By the way, if anyone wants to submit a patch for that, it may not be a bad idea. If you want to get a patch into the Rust book. Okay. By all means, I think that that's right, and your citation for that should be the one above it, says self-output. So this should say self-output too, you know, for mirror purposes. Okay. Fully qualified syntax for disambiguation, calling methods with the same name. So here we have a trait pilot and a trait wizard and a struct human, and we're implementing pilot for human and wizard for human. And then what we're trying to do is we're implementing, all of these have fly. So all of these traits specify fly, and the question is which one do we call? So when we say let person equals human and we say person.fly, how does it know which one it's going to call? Right? And it says right down here it's going to print waving arms furiously. So we know it's going to be calling this one, the implementation on human. Right? What if we want to call one of the other implementations? How do we do it? If we know we have these three implementations implemented for human, how do we call the wizard implementation or the pilot implementation? Here's one example of how you can do it. Pilot fly, and we give it a person. Wizard fly, and we give it a person. Or person.fly, give it a human. So there's how that looks. We call that disambiguation, right? The other method is this method, which is the fully qualified syntax method. So we have a trait animal and a struct dog. We implement dog, and then we implement animal for dog. And now the question is, when we call, we want to call dog baby name, right? How do we get that? We're calling it by using the implementation dog, : baby name. So notice here, both sides of it are explicitly mentioned. And the same thing here, animal : baby name. We know what that's going to call. It's going to call this trait animal baby name. And then this here is this is the most fully qualified, right? Because this method, we're actually telling it what trait we want to source. So we have to give it the trait and the function. So type as trait. So if I want to do this and I want to call human, I can do human as dog, human as animal, right? So you can say human as animal dot baby name, and then what we're going to get is the baby name puppy. So you can still access that function. Does that make sense? You have different traits which have the same function name. They're all implementing a function called fly. So the question is, when you call fly, which one of those traits defining the behavior fly do you want to use? Remember, we talked about inheritance. And when I talked about inheritance, I said that inheritance essentially means you call the one closest to you. So if I'm a person, and I descend from Homo sapiens, which descends from animal, when you call fly, you're going to ask me, do you implement fly? And I'm going to say no. Then you're going to ask my parent, and you're going to say, do you implement fly? And he's going to say no. My parent would be Homo sapien. Then you're going to ask his parent, which is animal, and say, do you say fly? Do you have an implementation for fly? And he'll say yes or no. And at the end of all of that process, method dispatch, you're going to have some kind of method. Rust does this differently. Rust doesn't have a notion of this trait is above this trait, which is above this trait. It has a notion of these are all of your behaviors. So the question is, how do you differentiate between those behaviors? You do it explicitly. Say, I want to call the behavior of fly from animal or whatever, bird. And that's about how you do this. You'll only ever have this problem if you have two traits that demand the same function. Struct wrapper, vex string. Yes, okay. So here's another thing. You talk about encapsulation. You'll frequently do this in Rust. I actually hate this. So I am trying to change the language to get rid of this. I've voiced my opinion on multiple different occasions. This is super annoying. This is probably my least favorite feature of Rust. So there's this thing in here that's called the new type pattern. And essentially, you create a new type called wrapper, and it only has one thing in it, the vector of string. And why do you do this? You're doing this because you want to implement format display on a vector of string. Why can't you implement format display on a vector of string? Does anyone know the answer? You should know the answer if you're that far in that book.
I think I'm in the chapter that's talking about this right now, but I don't think I've read it yet.
Okay.
So
Rust has these things called the coherence rules, and if you've read about those, that's why. You can't define a trait, right, that someone else has created for a type that someone else has created. That's the rule in Rust. You can define your trait for anyone's type, right? You can define their trait for your type, but you can't define Bob's trait for Mary's type. That's the reason why that all works. So this pattern has emerged to solve it, which I think is really stupid. The language should fix this. So implementing format display for a wrapper, because you can't implement format display for string. Now, I think they have relaxed this in the latest version. I think you can actually define format display for a vector of string, just in this one case, because this case is super annoying too. But in many other cases, you won't be able to do it, and this pattern of wrapping a type to implement your own traits on it is very, very popular. And when they fix that, we're going to do a ton of code. Okay, this is a gauge you can do. You can do type synonyms too. You're creating a type called kilometers, which is I-32. Now this is going to, in every way, shape, and form, act like an I-32, but you can implement your own stuff on it, right? You can demand other functions only take a kilometer and then reject an I-32. This is essentially implementing an extension of the type system, even if it does nothing differently internally, for the purposes of you and what you want to do with it outside of that, right? Like for your application. Generally speaking, you won't do this stuff. Box, defining here a dynamic function that implements send and static. Yes, so this is really ugly, right? You probably won't ever see that unless you're writing library code, right? That's somewhat complex. But you can do this kind of stuff where you're implementing, where you say, you know, like, you don't want to write this kind of code, right? You don't want to write code that has this type. You want to write code that has some kind of like logical type. So what do? You call it thumb, right? Or you call it something else. And that implements, now you can call this thing here by its name, thumb. So now f is a thumb, and it's defined like this. And by the way, a thump is a real popular idea in computer programming. It's essentially a closure that always returns something, but not you don't know until you evaluate it. You know? So it's useful for some pieces. All right, format and IO error. Okay, so we create this public trade, right? I don't know what to do with this shit. Does anyone have any questions that they really want me to go over in this? We can keep running through this stuff. The advanced types thing is getting more and more advanced by the minute. And we've already gone over a lot of it, I feel like. I feel like I'm rehashing things. Does everyone remember this? This is the generic type implementation. So for every type T, we want to implement for every option T, right? We're creating a type variable called T. For every option of T, we're implementing unwrap. What is unwrap going to return? It's going to return the T, right? So if you want to implement unwrap for an option people, you can do that. What is it going to return? It's going to return people. And then here's a new structure called loop, and the expression of a loop is this thing, right? That's the type of a loop. I said here, remember we went over Rust and we said, Rust, everything always returns the last expression. So if you put a semicolon after the last expression in Rust, what does it return?
It's going to turn empty tuple.
An empty tuple, right? That's the unit tuple, right? What if you have this as the last expression? What is it going to return?
Whatever that is.
That's right, this thing right here, the exclamation point, that type. All right, generic, this is a type T, defining the T. This is a T that requires the implementation of the straight size, and this one implements questionably sized. That means it doesn't require that. This is the default. Every T in Rust must be sized unless you implement this. Right? And the reason for that is somewhat complex. Advanced functions and closures. This is the difference between DIN and implementation. DIN does dynamic dispatch. Implementation doesn't. So we also went through that. I told you that you have this concept of monomorphization, generating the code for each different type. That's what DIN is going to use, right? And we have this other concept of, monomorphization is generating the code for every type. In that case, you're getting different code. In the case where you have dynamic dispatch and you generate one block of code for all of the types, then you're doing what DIN does. This function here, returns closure, is going to return something that, well, that's not how it actually works. Yeah, I don't know what they're trying to do. It doesn't apply. This function here is going to return a box of something that implements this closure. Takes an I32 and returns it. Macros, we're not going to go over that. If you're interested in macros, this is not the right book. This is a really brief explanation of macros. There's a Rust macro book. We're also not going to go over chapter 20 because this is a whole other class, and I think we asked whether or not we want to do it. We said no. Chapter 20 is building a multi-threaded web server. This is an extension of peerless concurrency, right? So this is actually going to be more about what the web server is doing. Listening for a TCP connection, TCP listener, turning a single-threaded one into a multi-threaded one. This is how you break down the code and restructure it. And then graceful shutdown and cleanup. This is going to be how to do things like drop on the thread pool and other few things. We went through all of this stuff. This is just the application that you're creating with it. And if you understand the application, then you probably have a really good command of what the book is taught, and you're ready for that, which is the next step I would do. All right, I think we have some time, and what I would like to show probably now, because we're almost 7 o'clock, no, we're 8 o'clock, so another hour, but I'm not gonna waste another hour of your time. What I would like to show though is wrestlings. How many people here have used wrestlings? Okay,
Used a little, I thought. Okay.
Max, you never used wrestlings?
I've never used those, I don't procrastinated on, I'm gonna use it.
Okay,
Actually, do you know where the Ethernet port is? Because I brought the Ethernet port.
your computers that have Wi-Fi?
It does have Wi-Fi, I just don't mess with Conman CTL. He's dumb.
Are you using Arch?
Yeah. I'm using Artix, Alright, it's different because it uses, run it.
But you can't get on a wireless network.
Yes, I can. I've done it before, yeah. I have done, I
How
don't
have you
know
done it
if
before?
Not here, but I've done it before. I've done Wi-Fi. But it's just,
I'm
it
just
doesn't
saying,
act,
at
it
the
acts.
point that your operating system is sort of not user-friendly, you can't access the wireless network, reconsider those priorities.
I honestly, man, like, I'll be honest with you.
Be
Kind of
honest?
my bad. I kind of know how it works on a more spiritual level, you know what I'm saying?
Yeah, you're one with the computer.
Unironically, alright? I know that I can't let this turn off with Ethernet connected or we'll lose Wi-Fi. Like, it does some weird stuff, whatever. Magic.
So, for those of us that are new to Linux, right, I will explain to you what is happening.
Please inform.
Linux has a bunch of different distributions. Those distributions all have different attributes and different levels of complexity, and they're out of that complexity, right? You can imagine there's a spectrum, and my good friend of the spectrum over here, that spectrum ranges from practical, as in I need to get shit done, to oh my god, what am I doing, right? He has chosen to use a very special distribution, and then that special distribution that he's used wasn't special enough for him. So there's like 3 dudes that have taken it and made it even more esoteric and not user friendly by stripping out System D, which is our method of doing everything. And now he is on a path that is what's the Robert Falk or whatever quote, you know, that has never been trodden. No one here is going to have a baseline to compare with.
And that's the fun thing about it, though.
By all means, it is fun. Unfortunately, you're even above my expertise.
I'm gonna be honest with you. I've kind of also let my particular Arctic little operating system fall into disrepair. It's also it's about the me being not proactive enough to like actually fix it. Because I just like using Ethernet better. I don't know, it's faster, and I just like using it more. I mean, it's usually just always coming from my DOS instead of Ethernet. So I'm fine with using Ethernet only. But
I love Ethernet too. I mean, I'm a geek, but I mean, the unfortunate reality
yeah, and
is...
also it's just, I think I could have chosen something different for
Yeah,
a
something
client,
that's-
but I chose Conman CTL, which I'll be honest, really bad client, well not, console interface, whatever, command line interface, it's very bad. It's not cool, it's not helpful. The help message just shows all the commands you can do with no explanation, or very little.
I mean, I remember the days that you're talking about, before System D and before, you know, Linux went through all of its usability bends, and I don't miss it. That's a hard life, man.
Makes you better though. You know what they say, pressure makes diamonds. I'm not wrong, am I?
I mean, you can Google how to get Conman CTL working with your cell phone.
Oh yeah, I was gonna do that earlier, but I'm like, I'm just late.
Hey, you're gonna diamond yourself here. All right.
Oh,
So what we want to do here is I want to get this wrestling thing started because I want to run through a couple of them with you so you understand what this is about. So there's 2 things here. There's the book, which is the one we've read. There are more or less there are lots of books for Rust that are totally and utterly free. None of them live up to the one Josh has. If you want to learn it thoroughly, that's the one I suggest. But we have done the book. The other one is called Rust by Examples, and Rust by Example is showing you with little examples everything, rather than telling you theory and teaching you, right? And a lot of people learn by that method. It used to be called the cookbook method. You see little recipes. Now they call it by example, which is probably more accurate. There's also another book too for advanced, if you're looking to advance and you don't want to spend $50, there's the Rustonomicon, and there's others. But what we're going to do is we're going to essentially install this, and in order to do it, I go to the repository, and then I just go cargo install force path, right? So we're going to go down here, I'm going to go, boom, code, HTTPS, git clone, boom, cloning, Rustlings, and I'm going to do cargo install. Force. And it's going to go ahead and build it off.
Thank God for Wi-Fi.
Was that?
Thank God for Wi-Fi.
Yeah, I know. By the way, did anyone notice this font here? I haven't.
Stinky. Ooh, that's what you get. That font.
By the way, I didn't know that that light was on. If anyone had problems seeing, I always advise people to say
That's
something.
good.
Oh, wow, look at this. Look at this.
Probably doesn't matter as much unless I'm using my color theme, which is better than everyone else's. But this is actually
Blue.
Comic Sans.
I could not get on
Hurts my
board
eyes.
with the bright blue background.
Yeah. Well, it's good with contrasting specifically in the color yellow. It's very good. It keeps your eyes awake. It's like injecting liquid crack to your eyes.
Well,
You know that you should have.
if there's one area of expertise that I don't want to challenge for you,
It's chess.
that of liquid crack.
Chess. I don't know. You know, actually on Wikipedia, the Wikipedia page for crack does tell you the chemical formula. And some pointers.
Why are we on that page?
I don't know. Here's the idea. I saw a screen cap for it.
You're asking all the right questions.
I saw the screen cap for it. Someone sent me a screenshot of it. I'm like, this can't be real. I looked it up and it was. It was incredible.
Was it now?
It was. I would not tell a lie. I'm like George Washington.
Who was known
I thought he chopped down a cherry tree.
I didn't lie about it.
I did the same thing. So I can't tell a lie. or something.
Yourself then.
was Abraham Lincoln
Yeah, I
that said
thought
this
everyone
until
wanted
line.
to
Oh, whichever president does. Because I'm basically all the presidents in one.
Okay, so I want to show you this.
You know, they actually were like, they had like, DEA agents, like pull Aaron Paul next to the room and talk about it.
Okay, so on the right-hand side, you are going to see me running Rustling's Watch. Rustling's Watch is going to tell me different things about what I'm currently looking at, right? And it's telling me there's a problem in this script right here, exercise intro 1.rs. I'm going to copy this, right? And I'm going to go right here and I'm going to go vim, boom.
It's because it exercises. You're already an exercise.
Yeah. Good job, you provided value.
Always do.
Okay. Let's do this a different way. There we go. There we go. Okay. So now I have the ability here to look at this, and what's the problem with it, right? The problem is, it says here, you can jump into the working on this exercise, or jump into the next one by removing the I am not done comment, right? So this is very simple. This one is like the simplest one of them all. And what we have to do is, in Rustlings, you solve the exercise, and then, when you're content with your solution, you remove this line right here that says, I am not done. I'm going to remove that line, and I'm going to write this file, and you're going to see the bottom update, and it's going to complain about the next one. So now it's complaining about intro2.rs, right? So I can copy this, I can come up here, I can open this file, and now I look into this code, and what is it complaining about? It's complaining because I have these brackets here, but I'm not providing a variable. Right, so if you're familiar with the print line format in Rust, I need a variable. So I'm going to say comma, and then I'm going to say world, like this. Right? And then I'm going to write it, and now it's going to compile. It's going to say hello world, And I have to do what? Remove I am not done. Remove that, write it, and now we're off to the next one. Exercise variables, variable 1. I'm going to come back up here, I'm going to edit it. And in this one, what do I see? The problem is this, x is not found in the scope. So I have an x variable here, and it's not found in the scope. And it even tells me right here what I have to do. I have to declare it first. So I declare it by putting a let in front of the x. I'm going to come up here, I'm going to say let, write this, and we're off again. So now I have the next one, which is, oh, I have to remove the I am not done. Now I'm on variables 2. And here, what's the problem? The problem is I don't have the type specified. So I need the type. So I can just add the type, U32, write it, and then I have to remove the I am not done. And it's complaining. Why is it complaining? Let x. Oh.
It wants you to initialize x because it's never being assigned, it's just being compared.
Oh, okay. Let x equals 0. And here, let me show you something here with this too. This is a great example. So you're exactly right, Josh. I can save it like this, right? And now I know it's working. X is not 10 is the output, which is running right here. And it says I have to remove I am not done. Now, you remember the literal syntax for this?
Do I remember the literal syntax?
Yes.
For
For a 0 that is a U32.
So like, where you like put the type on the back end of it, like say 0 U32 or whatever?
Exactly. I can delete the type on the front end and say let x equals 0 U32. Like that.
Yeah.
And that'll also work. And I can
Went
confirm
over that a
it.
few days ago.
There you go. See, so that's all in that book. And then it'll run fine. You know? And then the next one it's complaining about is probably going to be variables 3. I should probably make this a little bit bigger. Variables 3.rs. I'm going to open up that file. Okay, what is it complaining about? It says that x is used here, but it isn't initialized. So I just need to simply initialize x. We're defining it as 932. I'm going to say it equals 0. And now I just need to remove the I have not done. And variables 3 is done. And now we're on variables 4. What's the problem? Cannot assign twice to an immutable variable. What do I do here? What do we call this?
Well, sorry, sorry, what exactly are you asking?
How do I solve this problem?
Oh, you make x equal.
Okay, there's 2 different ways to do it. What's the other way to do it?
Without changing that line.
Ah, okay, I didn't see it. It said don't change this line. Okay, so yes.
You could shadow.
That's exactly what I'm looking for. Good job on both of them. So that's exactly right. So this will work. I can say let mute x equals 3, or I can break the advice right there, and we can shadow by saying let x equals 5. Excellent job, Josh. You're on it. And let's leave the I'm not done, and we're off to the next one. This is how wrestlings work. So we've already went through all the different variables, and we've read about how they work. And now wrestlings is going to show you each and every little piece of minutia, you know, as you digest one piece of minutia at a time. There's probably, I would say, maybe on the order of 150 Rust exercises, or at least there was when I was continuing the project. I don't know, maybe more.
Or mine was 94, but I might have an old repo. I haven't updated it in months.
Or maybe they made some of them smaller, or they stopped going as deep as they did before. All of those are possible. But anyway, the point is, whether there's 94 or 150, there's a ton of these things that cover a whole swath of the language. So it's a good place to go when you're finished with the rest of it. All right, anyone have any questions?
Yes.
Yes.
Any chance that we're gonna do another Rust class kind of like this in the future, you know?
You were here the first day. Why didn't you
I was
attend?
not here the first day.
You were here the first day.
It was like the 5th or 6th chapter before I knew y'all were doing this.
Yeah.
I don't look at Discord all the time.
I don't have a problem doing another Rust class. It really depends on demand, you know?
All
I
right.
mean, I can tell you right now, Josh will be bored out of his fucking mind. He's been glued to this thing. He's done. He's gonna be, he'll be
Forget it.
working on Rust Dev 2 before we
Wolf
start
Wolf
that.
Warcraft's gonna rot his brain, he's gonna need a refresher.
It's not rotting fast enough, look where you come.
I know, he's kicking ass on
He's
that.
kicking ass. That's right.
The good news is, he's not gonna be independent much longer.
Well, the good news is that when he's not a dependent much longer, he'll be having gainful employment using Rust.
Exactly, that's what I'm saying.
Yeah.
Yeah.
I don't know if you're talking about legal dependence or.
No.
Yeah.
I'm just happy to know, your offspring are not gonna be,
There we go.
gonna be able to support themselves. All right, so,
He's got it.
yeah, I mean, I think you did a fantastic job with the Rust class.
Thank you so much.
Yeah, we appreciate you, for sure.
Cool. By the way, just so everyone knows how the group works, this Rust class, 100%, was started because of Max and his dad. They're the reasons why the class got started. So, you see what they're doing in the other room? That's totally cool. We're here for that. You can come and you can play board games, you can socialize, you can bring projects, you can co-work. We're a great space for all that kind of stuff, network. But when you ask the question, you've been coming here for 6 months and you're not learning something, the way to change that is to say, this is what I want to learn, this is what I want to get better at, this is the tool I want in my shed. You come and you say, I want to learn Rust, we'll do a whole entire 20-week class for you so you can learn Rust. It's not that bad for me. Actually, the second time I've done Rust. I've also done 2 or 3 classes on JavaScript and Python. So I think Max has learned an ass ton of Rust too. You've done fantastic in this class, you really have. And I really feel like you probably know more Rust than you know any other language, and you could probably write something useful in Rust or struggle with it, and figure it out. You know enough to start the learning process now better on your own. So that's how the process started. We enjoy the class, we enjoy HLUG as a community, we want to get more out of it, let's run the program. So the next thing we're probably going to be doing is PostgreSQL. Other things that we could do that people have wanted, Kubernetes. We certainly have a lot of that expertise in this group now. We've done Angular, we've done JavaScript, we've done TypeScript, we've done Python, we've done Forth, we've done reverse engineering, we've done C, and that's all I know. So that other group up there.
Is Kubernetes more esoteric though than Postgres?
It depends on what industry you want to get into. So far we've covered a lot of different discrete little industries in IT. So certainly, like, if you're being a programmer, you're going to have to know everything Josh knows. He's set. You got to know what the stack is, the heap is. You got to know how to write all this code. He's got all that foundation now. This is good if you're going to become a developer. There are other career paths out there that have nothing to do with it. You could also do like, for instance, Kubernetes, which is cluster work, right? You could go work for Amazon, which is essentially like a gigantic Kubernetes cluster, and learn how to maintain and monitor Kubernetes as a cluster. There's a ton of jobs out there that run private clusters. This is something that I particularly have had a lot of experience with because I didn't go to college. I just came to this group when I was in high school. So that's my background. But now that I'm at cPanel and they can move me wherever the hell I want, and they're willing, because I know can jump in these areas, they put me into this cluster stuff. And I'm learning expensive clusters and how they work and how we can make programs not just run on multiple cores, but on multiple machines with multiple cores. And how you can have redundant storage so you can use hard drives and machines with hard drives and not lose data. So this is more like what I'm doing right now. It's also what Ed does right now. So insofar as we're the 2 most knowledgeable people in the group, we're both working now in clusters. It is more esoteric, probably. There are probably fewer jobs with it, but it's also extremely popular. Having private clouds and understanding how to do cloud stuff is a real big industry, and it's looking better.
So Kubernetes is very intimately related to cloud stuff. I never really thought of it that way.
Yes, entirely. Kubernetes is for companies. For a long time, they would say something like, I want to run my own email server. How do you run your own email server? Thanks for that. We have 45 minutes. So if you're a company, you say, like, how do I run my own email server? How do you think we'd answer that?
Yes.
No. Linux, right? Install Linux, apt-get install your email server. We'll help you set it up. That's how we do it, right? The problem is now, when a company wants to install their own email server, they want it to run on a cloud because they have a cloud. It's their infrastructure. It's already set up. So they want to know that one machine can fail. They're still functioning for email. They want to know that they can use a hard drive that's still functioning for, they still have all their data. How do you answer this question? right? So if you're on Linux and you've been developing over the past 20 years, what you probably say is, well, you need redundant storage, Ceph, you need something like, Heartbeat to say this needs to be copied over here so you can have failover. These solutions are getting complex. Now what everyone does, you take the whole series of machines, you make them all nodes in a Kubernetes cluster, and you deploy applications on that cluster as if it was Linux. So you don't run apt-get install xm to install a mail server. You run helm install, xm cluster, and it installs the cluster version of it. So it's about looking at a cluster as a single machine and installing applications on it. That's a huge part of what I do. Let me give you a case in point. Well, let me derail this conversation then with something. This here is called MinIO. God, always when I'm doing something. One second.
I have a Rust-related question for you.
Yes, what is the Russian question?
Oh, no. I wasn't prepared for this.
You always have a moment.
Is there a big community for writing audio plugins for Rust? Because I know there's one framework called Juice. I'm not sure if you're familiar with that.
I'm not.
It's like a C++ framework for writing audio plugins. I dabbled with it a year and a half ago. I'm just curious to know how much you know about writing audio plugins.
That is going to be way outside of my forte.
Got it.
However, I do imagine Rust is used in that field,
Yeah. Figured you'd be the guy to ask.
kubectl get pods. Okay, so I thought I had a demo for you. kubectl get pods and minio dev. Okay, so it's not ready. So this would be an example of a Kubernetes failure. kubectl describe pod minio.
What are you trying to pull out? Is this?
I had literally just, while I was at Renewage, has anyone ever heard of S3 or AWS?
Yes, I've used an S3 bucket before.
Excellent, okay. So, having used an S3 bucket, right, what you've done is you've used a proprietary Amazon storage system that uses buckets, right? Container that I use in K, which exceeds the request of 0. Okay, so the problem is that I've actually run out of memory, so I need to take a look at that. But anyway, I can look at this later. The point I'm trying to make here is that S3 is like an Amazon, it's like a proprietary Amazon service for storage, right? If you are a company and you want to get away from Amazon fees, what you can do is launch your own Kubernetes cluster and use this thing called MinIO. And MinIO allows you to have your own S3 cluster, right? So I can take MinIO, launch on my own Kubernetes cluster, and not pay Amazon anything. And any program that works with Amazon will work with MinIO. So it's a great example of having the cluster tech that you have. And where is this really useful? Well, you go to a company like cPanel and you say, hey, you're paying $100,000 a month to Amazon. Why don't we host our own Kubernetes cluster and we can get it down to $10,000 a month or something like that. Now you're bringing $90,000 of value by maintaining and running that Kubernetes cluster with MinIO. So it takes a lot of hard drives to equal $10,000 a month. Clouds get a lot of premium because they're providing highly redundant storage with high uptime ratings. But if you know how to do it yourself and you don't get these stupid errors, you can undercut them substantially.
Could you, in a home lab situation or for your own personal use, have a Kubernetes cluster yourself, or is it's beyond the?
We do that all the time. We've done that in the group multiple times. Actually, Nikolai was really big into that.
Yeah, I remember that back in 2011.
Kubernetes
Oh,
cluster.
they keep the little lightning talk and a little stack, a little small computer or something.
Yeah, he had a whole cluster of Raspberry Pis, a bunch of little small machines.
Yeah.
And you're okay, this isn't my cluster. But I'm running essentially Kubernetes right here on one machine. So you can have a home lab with one machine. You don't have to have 10. I never understood why Nikolai liked to do it that way. But I don't. I like the least esoteric option.
It looks really cool to have 10 Raspberry Pis all lined up.
It does look really cool, yes. But you have multiple different cores, you can run them all on the same machine.
Yeah.
So you can have a home lab, yes. I use K3S, another option is Minikube, we'll use our home labs for Kubernetes. All right, anyway, talk about it in chat and see what you guys want to do next. If you have something you want to learn, give me a shout, and we'll do it. I know that the ones we have the skills for in the group, the big ones anyway, Kubernetes, C, Linux, JavaScript, TypeScript, Python, Rust, Angular. If any of those are interesting, that's where we're at.
Evan,
in Postgres.
so I go look up this particular, because I already got it, like, that's a particular thing. It's not protecting the carrier for my Wi-Fi or whatever, right? I'm content. Look this up, multiple different forum postings, and they all come down to, oh, Conman is blocking your Wi-Fi from working. And I think that's funny, because whatever, right? But beyond that, the general consensus is that you don't use Conman because it's trash, and you use Network Manager. And you know what? Honestly, this is an L upon my forehead because I decided to install it and use it on a operating system where you install and use what you want to use.
Well, what I don't understand is why are
But I just think that's funny. But across Ubuntu, Arch, Arctics, and a bunch of other miscellaneous forums, everybody agrees upon the idea that Conman is trash.
But if you poll enough people, they're going to say anything that's not System D is trash. Why aren't you using System D? 99% of Linux users use System D. Every enterprise uses System D. Why would you not use System D?
I just don't want to, man. I mean, like, can you even debate that? I just don't want to.
That's
You know
totally
what?
fine.
The biggest thing I don't like about it, the biggest thing I don't like about it,
You got style. I'll give you that. No one's
Biggest thing I
going
don't
to
like about
learn.
it, when it's starting up processes, it doesn't give me an okay if they work.
It'll tell you whether or not a process fails.
But it doesn't give you that cool OK box that OpenRC does. I want to look cool, alright? I want style, I want to look cool, I just don't want to use System D. That's it, man.
Nothing wrong with that. You're going to
Exactly.
learn, but you're going to learn by working with the trash that you're lambasting. You know? I mean,
Hey, man,
that's how
it's
it
way
is.
cool, dude. I don't know what to say, it's way cool.
You're going to learn a lot.
So you may run into people who don't want to solve his Wi-Fi connectivity problem.
I'll try to help you out with your Wi-Fi.
I'm gonna be honest, the Conman CTL stuff was actually something that was kind of disconnected. Even the people on Arch, who had System D, of course, they were talking about Conman, it's kind of bad. It's not good.
I mean, what you're doing is not in my opinion, it's just simply not what I want to learn. But by all means, I think you're going to learn. So